Right, in this video here, I'm going to be talking about the inverse tangent function. Now, if you haven't seen the other videos that I've done on the inverse sine and inverse cosine functions, I would advise you to maybe look at those before you watch this one. They're all fairly similar as far as what we have to do in order to get the inverse function and how the inverse function is defined. But you need to know about all three of those, the inverse sine, inverse cosine, and inverse tangent. Right, so for this one, here's the graph of the tangent function, right? Y equals tangent of x. That's what the graph of tangent looks like. Now, remember, in order for a function to have an inverse, it has to be 1-to-1, meaning it has to pass the horizontal line test. Now, obviously, the tangent function here does not pass the horizontal line test. Any horizontal line that I draw anywhere is going to intersect the graph of the tangent function an infinite number of times. Remember, it's not just these three here. It keeps repeating that same pattern over and over again in both directions forever. Right, so obviously the tangent function is not 1-to-1, right? It miserably fails that horizontal line test. Right, so just like with the inverse sine and inverse cosine functions, in order to have an inverse tangent function, we need to limit the domain of the tangent function. Right, so we need to limit the domain in such a way that we get all of the y values of the tangent function, which is all real numbers. Right, these little branches of the tangent function here, one side goes up towards positive infinity, the other side goes down towards negative infinity. So basically, we just need to take one of those branches, right, which will go all the way from negative infinity up to positive infinity, and then one of those branches hits each of those y values only one single time. And the one that we take is the one in the middle here, from negative pi over 2 to positive pi over 2. So let me erase the other sides. And you could take any one of those. Like if you take any one of those branches there, like the one I just erased from pi over 2 to 3 pi over 2, that one is also, if you erase all the other ones and just keep that one there, that would also be 1-to-1, and you can define a tangent inverse function from that. But some mathematicians at some point decided, well, which of these are we going to use? Well, let's use the one right in the middle, the one that goes through the origin. That seems like it makes the most sense to use that central one. And so, while we have a number of choices we can use, mathematicians decided, well, we're going to limit the domain of tangent to be in between negative pi over 2 and positive pi over 2, and then that's going to make this tangent function 1-to-1, right? Because now we cover all the y values from negative infinity up to positive infinity, and we pass the horizontal line test, right? Because the horizontal line only hits each graph, or only hits that graph at one single time, which means it's a 1-to-1 function, right? Remember, 1-to-1 means for each y value, there's only one single x value. All right, so this function now, this tangent function, is now 1-to-1 if we only use the part of the tangent function that's in between negative pi over 2 and positive pi over 2. All right, so that's how we limit the domain of the tangent function. And if you watch the videos that I did on the inverse sine function, the inverse cosine function, we had to do something similar for those functions. Chop off part of the graph so that the piece we have left is 1-to-1. All right, so there's our tangent function. So the inverse tangent function, remember, inverse functions switch the domain and the range, right? So for the tangent function, the domain here was from negative pi over 2 to positive pi over 2. For the inverse tangent function, the range is from negative pi over 2 to positive pi over 2, right? The x values here become the y values for the inverse, right? For the tangent function, the range, the y values were from negative infinity to positive infinity. Well, that becomes the x values for my inverse tangent function. Here, my x values go from negative infinity to positive infinity. All right, so this is the graph of the inverse tangent function. The range of it is negative to positive infinity. It goes all the way to the left forever. It goes all the way to the right forever. And it has horizontal asymptotes at negative pi over 2 and positive pi over 2. Right, whereas the tangent function had those vertical asymptotes at those points. Right, again, when we do the inverse, we switch the x and the y, so the vertical asymptotes here become the horizontal asymptotes over here, and our graph, as we go off towards infinity, this graph will get closer and closer to pi over 2. As we go towards negative infinity, it's going to get closer and closer to negative pi over 2. All right, so that's what the graph of the inverse tangent function looks like. The definition of inverse tangent, right, so the inverse tangent function, tan inverse, right? So remember, that -1 exponent, that's the notation that we use for an inverse function. It doesn't mean tangent to the -1 power. It doesn't mean 1 over tangent. It means the inverse tangent function. Right, so it has domain, negative infinity to infinity, like we talked about, right? This graph goes to the left and to the right, both directions forever. And it has range, negative pi over 2 to positive pi over 2. Right, those are the two horizontal intercepts, and the graph is completely contained within those two horizontal intercepts. Right, notice the pi over 2 numbers here have the parentheses, not the square brackets. right? Because the graph never actually reaches and never touches those asymptotes, and so we don't include those points in our range. All right, so the definition, tangent inverse of x equals y, means that tangent of y equals x, right? Just like hopefully you watched the other videos I did on inverse tangent and inverse sine, it's the same idea here, right? When I'm trying to evaluate an inverse tangent function, they're giving me the output value, and I have to figure out, well, for what number that I put into the tangent function is going to give me this output, right? So it's switching the inputs and outputs from the original tangent function, right? And the tangent inverse function is also called arctangent, right? Arctan. Arc refers to an arc of a circle, like a distance around the circumference of the circle. So we can use these inverse functions to measure distances around a circle, which is something I'll get to in a future video that I do. Not quite ready for that yet based on the things I've done so far, but we're kind of building to something like that, right? So that's why they call it arctan, because you can use it to measure the arc length of a circle. All right, so that's the definition of the inverse tangent function. The key things to know here are the range, really, between negative pi over 2 and positive pi over 2. When I do the inverse tangent function, I can only give answers that are in between negative pi over 2 and positive pi over 2, which when we use the unit circle then to evaluate the inverse tangent function, we can only look at part of that unit circle to get our answers, right? And that's what I'm going to do now. So I'm going to pause the recording here and erase some of the stuff up top, and do at least one example, maybe just one, and then do another video with some more examples. But we'll do at least one example on this video of evaluating the inverse tangent function, just so you get an idea of how to do it and what that looks like. All right, so I put up here one example that we're going to do evaluating the inverse tangent function, tangent inverse of -1. All right, so if you watch the other videos that I did about evaluating the inverse sine and the inverse cosine functions, we're doing something fairly similar here, but for the tangent function, it's going to be a little bit more complicated because remember, for the sine function, the definition is just the y-coordinate of the terminal point. For the cosine function, the definition is just the x-coordinate of the terminal point. So for those, you're just looking at your terminal points and looking for the number, and it's just sitting right there. Remember, the definition of the tangent function is the y-coordinate over the x-coordinate. So to evaluate inverse tangent, we actually have to go to our terminal points and do the y over the x and simplify that to see if it equals -1 until we find the one that equals -1. Right now, it sounds like maybe a lot of work, but I'll show you that it's really not as complicated as it might sound. All right, so tangent inverse of -1 equals something, right? So remember, what that means is tangent of some number is going to give me a value of -1. Right? Remember, the definition of tangent is the y over the x. So I have to go to my unit circle, and I have to find a number on the unit circle where when I do the terminal point and I do y over x and simplify it, it gives me -1. Right? So that's the task I have here to evaluate the inverse tangent function. Now, before we jump in and do that, notice when I put the unit circle up here, I only put the right half of the unit circle. Right? The reason I did that is because the range of the inverse tangent function is just between negative pi over 2 and positive pi over 2, right? Because of how we had to, define our function and limit the domain of the tangent function, we're only getting values between negative pi over 2 and positive pi over 2, which means we're only looking at that right half of the unit circle, right? So just like with the other trig functions, sine and cosine and their inverses, we only look at half of the unit circle, right? For sine and tangent, we're looking at the right half. If you remember, for cosine, it was the top half. Right, so for each one, you just have to remember, well, where on the unit circle am I looking? Right, for tangent, it's just the right side. All right, so I'm looking at just the right side of the unit circle, and I'm looking for a value that when I do y over x of the terminal points, it equals -1. Well, first thing, if it equals a -1, that means when I do y over x, one of those has to be positive and one of them has to be negative. Well, that's not going to be any of those points from the first quadrant, right? So if I do the points in the first quadrant, both the x and y are positive, and if I do y over x, it's going to give me a positive number. All right, so since I need a negative value here, I know that it's going to have to come from that fourth quadrant. All right, so when you're doing inverse tangent, you can cut your number of choices in half right away. If it's a positive number in here, it's going to be coming from the first quadrant. If it's a negative number, it's going to be coming from the fourth quadrant, just based on the x and y coordinates of the points that you have there. All right, so I know it's going to be one of these numbers from the fourth quadrant. It's going to be either negative pi over 3, negative pi over 4, or negative pi over 6. Right? Remember, I think of those as negative numbers. I don't think of this point here as all the way around the circle and stop here, and that's 11 pi over 6. Since the inverse tangent function goes between negative pi over 2 and positive pi over 2, I have to think of these as negative values. Right? If you're not sure which one is which, they just reflect over. So if the first one up top is pi over 6, the first one on the bottom is negative pi over 6. And then pi over 4, negative pi over 4, pi over 3, negative pi over 3, and you got them. All right, so one of these ones in the fourth quadrant there, when I put y over x, it's going to equal negative 1. All right, now think about that. If I put one number over the other, it's going to equal a negative 1. Well, if I put a fraction together, the only way it's going to equal a 1 is if the top and the bottom are the same number, right? 5 over 5 equals 1. 17 over 17 equals 1. Right, so which of my points is going to have the same x and y coordinates? And if you're not sure, use your trig hand. Right, if I use my trig hand for the first quadrant, if I put down the middle finger, which corresponds to the pi over 4 up there, or if I put down that middle finger, I have 2 above and 2 below. That's root 2 over 2, root 2 over 2. Right, so my terminal point for pi over 4 is root 2 over 2, root 2 over 2. Right, and if I do y over x, that's going to give me 1. Well, if I reflect that point down into the fourth quadrant, the x stays as a positive root 2 over 2, but the y becomes a negative root 2 over 2. And if I do the y over the x, I have the same number over itself, except one's positive and one's negative. That's going to give me a negative 1. Right? And if you're not sure, you can check it out. So I'm going to take this point here. My y is negative root 2 over 2. My x is positive root 2 over 2. Right? The halves cancel out, the square roots cancel out, and I just get negative 1. That's what I'm looking for. Right, so that's how we have to approach the inverse tangent function when we are evaluating it. We have to go to the unit circle. We have to figure out, well, if I do y over x, is it going to give me this number that I'm looking for here? And for the 1 and the negative 1, it's pretty easy because that's always going to be, if it's positive 1, I'm looking at pi over 4. If it's negative 1, it's going to be negative pi over 4. If it's one of these other ones with a square root of 3, sometimes you try one and it doesn't work, so you try the other one and then you get it. I'm going to do another video where I do some more examples of inverse tangent. So what I was just talking about there, I'll show you on that next video. So tangent inverse of negative 1 equals negative pi over 4. Right? Because tangent of pi over 4 equals negative 1. Right? If I try to do tangent of negative pi over 4, right, I get negative root 2 over 2 over root 2 over 2, right, the y over the x, that's the definition of the tangent function. And when I simplify that, I get negative 1. So tangent inverse of negative 1 is negative pi over 4. Right, remember, for tangent inverse, just like for sine inverse, if you saw the videos I did about sine inverse, but if I have those numbers from the fourth quadrant, I have to think of those as the negative values, not as, going, 3/4 of the way around the circle and then whatever that number would be. Right? And again, that comes from how we define the graph of that function in order to get the inverse. All right, so that's one example of the inverse tangent function. Like I just said, I'm going to make another video now where I do some more examples like this, do tangent inverse of some other numbers. And you'll see after you do a few examples, I mean, there's only, 1, 2, 3, 4, 5, there's only 7 points on the unit circle that we can use for tangent inverse. And so once you do a couple of them, there's only 7. So once you do 7 problems, you've done them all, and then you just see the same numbers over and over again. So it seems a little more complicated than inverse sine and cosine, but I promise it's not that bad. Once you get a few of them under your belt, you just see those numbers come up again, and you got them. All right, so check out that other video that I'm going to do evaluating some more inverse tangent.